So the internet allows us to communicate on Earth, but probably one of the more interesting and fascinating questions that we can think about on a broader scale is, are there other forms of intelligent life in the universe? The size of the universe and just the statistics involved suggest that the answer is probably yes, but we don't have any concrete evidence of this. And so, to some degree, one of the most interesting, excitingly wireless communications that might take place over the next, probably not a few years, next tens of thousands of years, assuming our planet survives that long, is this idea of trying to communicate with or receive data from other civilizations. What form would that take? Well, we have to assume that anyone who's trying to communicate with us is a fairly advanced civilization. And the question of how to transmit data across vast reaches of interstellar space is not necessarily that different than the idea of transmitting data here on Earth. The nice thing in space is that to some degree there's much less interference, and so signals decay a lot less rapidly. But some of the various types of signals that scientists are looking for on Earth include very, very short but coordinated pulses of laser light. So that could be a way where we could send some other civilization thousands, tens of thousands of years ago could have sent those signals into outer space in hopes that we would observe them. And if we're listening carefully on Earth, we may be able to actually decode some of those signals. So this is an example of the type of observatory on Earth, and people have built these really interesting instruments that are designed to detect these tiny micro pulses of laser light that could, if we sort of collect them and analyze them, actually have a signal in them and not just noise. Because there's clearly noise coming at us from all different parts of the universe. And so finding the signal in that noise that could be something that could be beamed at us from people, creatures, some sort of intelligent life form in some distant part of the galaxy requires a little bit of care. We are also trying to initiate that conversation, and so this was the Arecibo message was something that was sent in 1974, and this was sent using radio frequencies. The message was designed to convey basic information about Earth and its inhabitants. So it included information about, it was designed to sort of show them what we look like and something about our DNA structure and stuff like that. The message was aimed at a particular location where we thought there might be a planet. So one of the things that we've gotten better at over the years with astronomy is detecting the presence of planets, dark matter that could be orbiting other stars that might be candidates for containing intelligent life like us. Now, if and when we manage to establish contact with these types of civilizations, we can be positive that the communication, at least if they don't leave their planet in sort of an Independence Day type invasion of our home, will be very, very low bandwidth. The M13 system that we beamed this signal at is 25,000 light years away, meaning that if we sent this in 1974, the earliest they will get it would be 2674. And then if they send it back, the earliest we'll get the response would be 51,974. How do you even say that number? That's so long. So we'll all be dead. We won't know about this, but certainly this idea of being able to communicate using the same basic wireless principles that we use to communicate here on Earth over vast regions of space, trying to answer this really, really fundamental question. I mean, is there anything that we could learn about the universe that would be more interesting and potentially civilization altering than the fact that there are other civilizations out there in the universe? And wireless signals, wireless transmissions may provide an answer to that question.